And I think now is a nice time to talk about how do you solve problems. It might feel a little bit late, but you know, I will say that the nice thing is that right now you're motivated. More than any other point so far this semester, you're highly motivated to solve problems. Of course, I should say you're highly motivated to solve 6 particular problems, but you know, at least you're motivated. That's the good thing. So there's some advice about how do you solve problems, and there's 4 steps. Now this is not me who came up with this. This is from George Polya, who's a really good mathematician who was at Stanford many years ago. So, okay, number 1. If you want to solve a problem, you should understand the problem, which means you read it and you think about the words that are used. What do they mean? What do all these different words mean? So one of the things we've been working on is translation. Things like if you see a phrase like find the derivative of something with respect to something, well, it means find the derivative, but maybe you'll say find how one variable changes with respect to another variable. Well, that also means a derivative. There's lots of ways to phrase the derivative. So take some time, make sure you understand what's being said, make sure you understand what's given to you. Make sure you understand what you're trying to find. Know what your answer should look like. If your answer is a tangent line, make sure you know that your final answer is a line. And you stop when you get to a line, by the way, that tangent line. And also think about how these things are connected. Now, we're going to give you, generally speaking, problems that you've seen before to a degree. Now, which is to say that there's no new ideas. We may present things in a new way, but there's no new ideas. We've seen all the ideas that we need. And many of the problems are going to feel very familiar. It's like, I feel like I've done this on a quiz, or I feel like I've done this on one of the practice tests. Because you will have done stuff like this on the quiz, or you'll have done stuff like that on the practice test. So that's why it's important to do the problems, those quizzes. Quiz 2 through 6, practice test 1 and 2. We're going to do practice test 2 in a few minutes. Think about the connections. Develop a plan. You've seen these problems before. How did you do it in the past? Pretty good bet it's similar to how you're going to do it now. So this is the good news. You don't have to create new mathematics. In fact, I strongly discourage it. There's so much new algebra that I get to see when I look at the solutions. It's all wrong, but it's fun to look at. It's not going to help you, though. So just do what you've done before. Figure out how you're going to do it. Can you solve part of the problem? We do give partial credit. A lot of partial credit goes to setting problems up. And it's amazing how you can get a fair amount of points without a lot amount of effort. So take some time and make sure you can say, look, if I can't solve the whole thing, let me get started. So, number 3, carry out your plan. Go step by step. And now, a word of warning. Some of the most common mistakes that I've seen, and I've graded by now tens of thousands of exam problems, is small things like inability to add numbers or copy numbers from one line to another line. On one line there was a T, on the next line it disappeared. Changed the problem. And it made it hard. Maybe there was a 4, and then somehow it became a 9. So be patient, double check your work. I know your adrenaline is pumping because you're just so excited. It's like, I've been looking forward to this date since I knew the test was going to be on that night. But you gotta relax. Find a way to calm down. It's okay to have a 2 or 3 minute panic attack at the start because you get 90 minutes. You can afford a 2 or 3 minute panic attack. Then after that, I'm calm. Better yet, have the panic attack before the test starts. Then you get that 2 or 3 minutes. And the last thing is not so much for the test, but it's good advice in general. Look back, look ahead. Can you check the result? That's an amazing thing to say. Can you check to see if your answer is correct? Is there another way you can see it? Or is it reasonable? And because you are not allowed to have calculators, your answers will be very reasonable. Because we have to somehow make the problems interesting enough that you can do them, but yet still have numbers that you can work with. And one of the things is, this is how you get good at problem solving, is after you do a problem, you say, look, I might see a problem like this someday again. How do I know what to do in the future? Which is why we want you to do these quiz problems. It's not just as soon as you do the quiz problem and after the quiz is over you forget them. It's, let's do the quiz problem. Okay, now what did I do? And how would I do it again? Okay, some other general advice. Be well rested. I have had people fall asleep in the exam. It's a bold strategy. Usually doesn't work out too well. So make sure you get plenty of rest. You're much better off having your mind function than trying to cram more material in at midnight the night before. Eat like you normally would. If you do some exercise, it's okay to do some exercise. Be just normal. Let your body be in its natural state. That's when it's happiest, and that will help you. I tend to discourage people from getting those extra big gulps and drinking like 128-ounce drinks right before the exam, because it can be a really uncomfortable 90 minutes if you need to go use the restroom. We do let you use the restroom. Just be comfortable. Make sure you understand ideas, not just procedures. I will tell you now, if you haven't heard already, there is a problem on this test. A good problem. One which I am excited about because I have not seen a problem like this on any Calculus 1 test I have seen. I have seen a lot of Calculus 1 tests. If you were to look at all the Calculus 1 tests that have been written at Iowa State in the last 10 years, you will not see a problem like this. And you haven't seen one on the quiz. What does it mean? It means the test is going to be fun. Now, I don't want to tell you which one it is, but you'll know it. You'll know it. And it's my problem. I wrote that one. I'm excited about it. After the test is over, you're going to turn to your friends and you're going to say, so what did you do on that problem? And you're not even have to ask, what do you mean that problem? Which one? You're going to like, I know which one you're talking about. This is what I did. And like, oh, yeah, I did that one too. Okay, good. Good, we got the same answer. It's not a hard problem. In fact, at the end of the day, it's one of the easiest problems on the test. But what we're testing is, do you understand? Now, that's a hard question. Do you understand things? And we're gonna find out. So, good luck. Good luck. Now, okay. Now I'll say something the opposite. I've made you very nervous. Be calm. Be calm. Look, you really do have all the tools you need. If you start to panic, then you start making algebra and arithmetic mistakes, and then you're hopeless. You're not going to recover. Work on the ones you know before getting stuck. So we are calculus people, and in particular mostly engineers. We like to optimize, get the most. And so that includes getting the most points. You're not going to get a lot of points if you start with problem 1 and you say, I'm going to just stick with this for the next 85 minutes until I get it. It won't take you 85 minutes. Problem 1 is like less than 85-minute problem. But just move around. If you're not making progress, it's okay to go to a different problem. You have my permission to move to a different problem. You don't need my permission, but you have it. And come back to it. Now, why? Well, 2 things can happen. 1, you work on another problem, you say, oh, wait a second, this is kind of like where I was stuck with the first problem. Now I see how to get unstuck. More commonly what happens is there's this wonderful subconscious mind that works on your problem in the meantime. And when you return, it will say, oh, you forgot to try this. And you're like, oh yeah, I did forget to try it. That's just what I needed. So it's okay to come back. Check your work. Again, nothing should get ridiculous. And the last thing I want to say, look, no matter the outcome, we still care about you. The calculus instructors you might think are out there are like, we are here to be miserable. We're here to weed people out of the engineering program. I haven't talked to an engineer other than students. I've never talked to an engineering professor. As far as I know, there are no engineering professors at Iowa State because I've never met one. You know, they didn't come and tell me, you've got to fail half the class. No, they haven't said that. What I want to do, and what our goal here, is to help you learn to think. That's what we want. And to get you there, we have to challenge you. And we challenge you not because we don't like you. We challenge you because we do like you. We only give our best problems to the people we like. And we like you a lot. So you're going to get some good ones. So anyways, there's that. Now, what do you need to know? If you go to the course website, there's actually a list of what the topics are. We are in phase 1, which is basics of differentiation. So this is nothing more than I just went to the course website and I copied what the topics for the first phase of the class are. So let's just read through it really quickly. You can go and grab them later. And of course, there's also the lecture notes. Average rate of change. How do you find it? Well, change in y over change in x. Instantaneous rate of change. What is that? Well, that's the derivative. So know how to find average rate of change. Know how to find instantaneous rate of change. Know about limits. What are limits? Well, that's what should happen based on what's happening nearby. Now, how do you actually evaluate a limit? Well, there's a couple of tools. Know all your tools. Factoring, that's if you have a polynomial. Know how to factor polynomials. Multiply by conjugates. That's really good for getting rid of square roots. Sometimes it comes in play when you do trigonometry and you have trig identities. Know sine x over x goes to 1. There's nothing sacred about x. Sine t over t goes to 1. Sine smiley face over smiley face goes to 1. Yeah, as long as, of course, the smiley face goes to 0. But anyways, the squeeze principle. Honestly, squeeze is a little subtle. I think that's less likely. Focus on the manipulation. Know how to move stuff around. Know how to work with one-sided limits. Those often come into play if you're working with things, for example, piecewise. Limits that involve infinity. That comes into play if you have horizontal asymptotes. Know what continuity is. Continuity is functions which have no surprises. What should happen is equal to what does happen. So you need to have the limit as x goes to a of f of x equals f of a. Know the types of discontinuities. The main ones are jump and removable. Know how to recognize those from functions and know how to recognize those from pictures. So you might see pictures on this exam. Know how to take information from a picture and translate that into a graph. Know the definition of the derivative using limits. Historically speaking, 100% of past Calc 1 exams at this point in the semester have had a question that says, use the limit of the definition. So I used the definition of the derivative of limits to find the derivative. Well, anyways, they're one of those questions is what I'm trying to say. Now, that's 100%. At some point, we're going to break that 100%. It may or may not be now. But playing the odds, know the definition of the derivative using limits. Good odds. Good odds. Okay, know how to compute and interpret higher order derivatives. Know how to find the different notation for higher order derivatives. You know, f double prime or d squared, dx squared. Find tangent lines. Tangent lines are fantastic. You need to know what they mean. Now, oftentimes you say, oh, it's a line. But another way to think of tangent lines is tangent lines are storing information. It's telling us what the function is doing. And in particular, the two things it's storing about a function is the value of the function and the value of the derivative of the function at the point where it's tangent. So you can oftentimes say, look, take a tangent line, turn it into two pieces of information. Conversely, if I have those two pieces of information, the value of the function at the point, the value of the derivative of the function at that point, I can get a tangent line. So you should be able to move back and forth between those two notions. Know all the rules for taking the derivatives, the sum rule, the product rule, the quotient rule, the chain rule. I left out the constant multiple rule. That one's so obvious that no one ever even writes it down. Powers of x, e to the x, sine x, cosine x, tangent x, secant x. You should know all those derivatives. And finally, differentiation as it relates to position, velocity, and acceleration. Okay, so that's it. That's pretty simple. Just know those topics and you're good to go. Any questions? And if not, any questions? Anyone? Anyone? There's a question? What percentage of what? The grade is the exam, like our total grade. Oh, you can find that on the course website. The percentage of the exam, I can't remember off the top of my head. It's somewhere between 0 and 100. I've narrowed it down to that range. I think, I don't remember exactly what it is. It may be like 16%, give or take. I don't remember exactly.
Which differentiation do we need to know?
The good ones. You should definitely know sine squared plus cosine squared equals 1. If you don't know that one, go get a tattoo. And then it's like, well, I'm sorry, you have a tattoo. We can't ask you to remove your tattoo. You know, it's a price to pay to learn that sine squared plus cosine squared equals 1. But it's a good thing to know. I would say know that one for sure. By the time you hit Calc 2, there are 6 that you should know. But start with sine squared plus cosine squared equals 1. That gets you pretty far. Anything else? Okay. Well, now that I have not enough time, let's go ahead and do as many questions from the practice exam as we can. Now you might say, but wait a second, you already posted solutions to the practice exam, but I didn't give you running commentary. You know, that's what you're paying for. It's like the director's commentary right now. What were they thinking when they wrote these problems? And by the way, these problems are not random. You might, some faculty like to say, oh, these are the rejects. Well, partly yes, but other things were written for very specific purposes, of which you will learn after you take the test. You're like, oh, that's why they put that one on there. Now I see it. Now I see it. Should have done the practice. Should have done the practice. Okay, so here we go. A particle moves along the real line with position given by this expression, e to the 2t plus 4e to the t minus 70 times t. Determine for which times t the particle is moving to the left, when the particle is moving to the right. Using that information, find the furthest left location that the particle will reach. All right, so here we have position. Now, it's asking about when it's moving left and right. Well, that's asking how is the position changing. If I want to know how the position changes, what do I look at? I look at what? Velocity. In general, though, if I want to know how something is changing, I look at derivative. So this is really saying, take a look at the velocity, which is the derivative. Okay, derivative of e to the 2t, 2 e to the 2t using chain rule. Derivative of 4e to the t is 4e to the t. Derivative of negative 70t is negative 70. Notice I took the derivative of each piece, and that was the sum rule. That rule is, some of these rules are like so obvious, they're ingrained, you've even forgotten that they're rules. That's the cool thing. They're great rules. Now, I want to know when something is moving left. I can reinterpret that as saying, well, it's decreasing. Its value is decreasing. So moving left says, okay, that's when the velocity is negative. Moving right, well, that's when the velocity is positive. So now I need to understand what the velocity does in terms of values, in terms of the signs, positive or negative. Well, let's look at this velocity, and I can't help but notice this looks like kind of a messy thing. 2e to the 2t plus 4e to the t minus 70. Now, I want to try to understand it better, so I'm going to try to write it in a different way. So first thing is, I notice everything has a factor of 2. I'll go ahead and pull that factor of 2 out. And now I have e to the 2t plus 2e to the t minus 35. And I say, Okay, so there's a lot of humming and hawing in the running commentary here, but that's okay. So now is the time to think, could we do something with this expression? So we know that calculus people love algebra. So we are like, let's think of this as an algebra thing. It almost would be cool if we could do something like factor. And the question is, could we think of this as a factoring problem? And then we say, well, e to the 2t. There's another way to think of e to the 2t. I can think of it as e to the t squared plus 2e to the t minus 35. That's absolutely true. Now you're probably thinking, yes. You could have also thought about it as e to the 2 to the power of t. But, you know, if I had written e to the 2 to the power of t, it's not as very convincing. Because this looks something like blah squared plus 2 blah, and again, this is just all mental, minus 35. And you're probably saying, yes, I know, you are mental. But I'm trying to get into that mindset. Think in terms of like an algebra. So it's like, oh, it's polynomial kind of, except instead of x, I have e to the t. Well, hold on. I can think of this as something like x squared plus 2x minus 35. What would you do? Yes, you would factor. You would take factoring into consideration. Okay, so it'd be e to the t, so like x. I need two things that multiply together give me negative 35, but added together give me 2. 7 and 5, plus 7 or minus 7? Plus 7, minus 5, because I need to have plus 2. All right. Now, this is good. Now I start to think, okay, e to the t plus 7. E to the t, can that ever be 0? No. Can it ever be negative? No. This is really very positive. It's always positive. And 2, I happen to have on good authority, is always positive. Which means I really, if I want to understand the positive or negative aspects, I need to understand e to the t minus 5. Well, let's think about e to the t minus 5. When does e to the t minus 5 equal 0? That's the same as e to the t equals 5. Or t is natural log 5. Okay, so we're almost there. So t equals natural log of 5 is sort of the key point. Now, suppose that t is less than natural log 5. So if I'm over here, t less than natural log 5, what happens to e to the t minus 5? So pick a number less than log 5. Say 0. E to the 0 is 1. 1 minus 5? Negative something. Negative 4. Okay. Which means that my whole velocity is negative. So if I'm over below 5, my velocity is negative. So what does that say about my movement? To the left, to the left. When velocity is negative, I move to the left. Right? Yeah. Good. We're halfway. There's a second round to that song. If I'm above log 5, pick a number above log 5. Like a million. E to the million is big. Minus 5 does nothing to it. So what is velocity? Positive or negative? Positive. So I'm to the right, to the right. When velocity is positive, I move to the right. Okay, so I've answered questions. I know when the particle moves to the left, when I'm below log 5. I know when I move to the right, and when I'm above log 5. So when am I furthest to the left? I'm furthest left at this value. Because before log 5, I keep moving left, 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 left. I'm somewhere. Then after log 5, I move right, 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 right. And so I happen to be furthest left at log 5. Now, the question says, where's the furthest left location? How do I find that? Plug it into where? Original function. So my furthest left location is s log 5, which is e to the 2 log 5 plus 4 e to log 5 minus 70 log 5. Now, what do I do next? Yes. Why? Because it didn't say we had to simplify. And if it doesn't say we simplify, don't. Now, you can if you want, but you're in danger. A person who likes to simplify is a person who likes to live dangerously. And we don't like to live dangerously. We're optimizers. We optimize. All right, number 2. A limit. Oh, I love limit problems. Find the limit as x approaches to square root of x squared plus 5 minus x minus 1 over x plus 1 times x plus 2 minus 6x. There's 2 limits. Let's do part A first. So I look at this and I say, okay, downstairs, I'm going to probably rewrite it. What will I do downstairs? I'll FOIL. I'll expand it out, gather terms, and probably refactor. Oh, by the way, what should I have done first before I even start doing anything? Always plug in the value. 3 times 4 is 12, minus 12 is 0. Upstairs, 4 plus 5 is 9. Square root of 9 is 3. Minus 2 minus 1 is 0. 0 over 0. 0 over 0 means more work. Absolutely. You got it. You guys are good. You guys are good. So downstairs, we're going to expand it out. Upstairs, what are we going to do? How do we get rid of the square root? Conjugate. And one other thing here is I'm going to just think of this x minus 1 as being grouped. So I'm going to put it like this. So minus parentheses x plus 1. Because when you have conjugate, it's something minus something. So I just want to make it clear that those other two things are going together. So multiply square root of x squared plus 5 plus x plus 1. Downstairs, have to multiply square root of x squared plus 5 plus x plus 1. Again, whatever you do to the top, you got to do to the bottom. So here's a place where people lose points. Do you notice what I did here? I rewrote the limit because I'm still taking the limit. If you're still taking the limit, write the limit. Okay, upstairs we'll have x squared plus 5 minus x plus 1 squared. Downstairs, okay, let's expand here. X squared plus 3x plus 2 minus 6x, we'll work on that. And then times that conjugate, square root of x squared plus 5 plus x plus 1. Okay, good. Well, we keep going. Upstairs, we keep doing algebra. That's x squared plus 5 minus x squared plus 2x plus 1. Notice something. I left my parentheses here. Parentheses are your friends because they will help make sure you don't lose signs. Because it's easy to not write a parenthesis and then forget that the minus distributes through to everything. Parentheses will help you. Downstairs, I'll go ahead and gather terms. So it becomes x squared minus 3x plus 2. Then I have my conjugate. Now you might say, hey, why didn't you multiply that conjugate downstairs? And the answer is because I love myself. And if I multiply it downstairs, I just make it hard. And I don't want to do that. Okay, so now we start our game cancellation. The x squareds upstairs cancel. And then what do I have? Well, I have a minus 2x. Then I have 5 minus 1. So I'll write this as minus 2x plus 4. X squared minus 3x plus 2, I think, well, that's probably going to factor. Because if something has to factor, there has to be a cancellation. And it turns out to factor to x minus 1 times x minus 2. And then I have everything else. Make sure I leave my parentheses on. Now, minus 2x plus 4, what's another way to write that? Yeah, I can factor out negative 2 x minus 2. That probably isn't showing up very well, but you can imagine that you could read that. And then you say, oh, check it out. X minus 2 downstairs, x minus 2 upstairs, and they cancel. And that's what our real goal here is. When we have some algebra over some algebra, our goal is get to a point where we get cancellation. And we just did that. All right. So all this time, we've been working to this point where we now have cancellation. Now what do? Plug it in. And again, watch this carefully. Notice I am not writing limit as x goes to 2 because I'm no longer doing the limit. Because I'm going to now give an answer. Because once I have this part upstairs, it's game over, man. Game over. Whatever happens, there's no more limit. Because I'm going to get something out. I can't get 0 upstairs. Negative 2 upstairs, downstairs, 2 minus 1. It's 1. Square root of 9 is 3. 2 plus 1 is another 3. So it's negative 2 over 3 plus 3, or negative 2 over 6. And I'm just going to be bold enough to say I can at least do that simplification. Negative 1/3. All right, so that's A. There we go. Now B. What's B? Find the limit as theta goes to 0. And I see I get a sine and a theta here. I'm thinking, oh, they're probably trying to test us on things like sine and theta coming together. They love that. So I'm going to start thinking about how to write these things. Okay, so I have 2 theta plus 5 sine of 2 theta. Now cosecant, what's another way to say cosecant? 1 over sine. So I'm going to put a sine 3 theta downstairs. That's cosecant. All right, well, what I can do is I can multiply top and bottom by 1 over theta. So that becomes the limit as theta goes to 0, 2 plus 5 sine of 2 theta over theta over sine 3 theta over theta. Now my goal is to get sine of something over something. I'm so close in some cases, but I'm not quite there. See, this is not sine of blah over blah. What's the problem? Yeah, this has a 3. This doesn't have a 3. How do we fix it? We put a 3. But we can't just put 3's, because that changes it. So we have to balance it out. There must be balance. It's like the force. There's the dark side and the light side. So I'm going to put a 3 up here. What do I do upstairs? Do a 2. So I'm going to put a 2 up here. And now I say, aha, I make a note. This goes to 1. This also goes to 1, which means that now I can say it goes to, upstairs, 2 plus 10. And the sine 2 theta over 2 theta goes to 1. Downstairs it goes to 3. 2 plus 10 is 12. Divided by 3, that leaves 4. And we're done. Good times. Good times. All right. Number 3. Suppose f and g are differentiable functions which satisfy the following. So I have this really big table here. So we can give you functions as functions, we can give you functions as tables, and we can give you functions as graphs. Be ready to see all 3, because who knows what you'll see. I do, but you'll know soon. So then you have this new function. H of x is f of g of x. Well, find the tangent line to h of x at x equals 1. Now whenever you think tangent line and you have a point, you translate that and say, really, that means I need to find what? Well, I need to find the derivative, and I also need to find the function at the point. So I need to find these 2 pieces of information. If I have the value of the function at 1, and I have the value of the derivative at 1, I have the tangent line. Because I can get from that information to a tangent line. So let's plug in 1. So h of 1 is f of g of f of g of 1. Now, this is an onion problem because it has layers. It's also an onion problem in that it might make you cry. But the important thing is when you have layers, work 1 layer at a time. Evaluation, you work from the inside. G of 1. Come up here. G of 1 is 2. F of 2. 3. G of 3. 1. F of 1. 52. Okay, there you go. Oops, I ran out of space. Okay, so that's 52. Now, halfway done. I know h of 1. The other half, h prime of 1. Well, before I can find h prime of 1, let's find h prime of x. So what rule do I need to take the derivative of f of g of f of g of x? Chain rule. Chain rule. Do the chain rule. Yeah, okay. Derivative of the outside? F prime of g of f of g of x. Leave the inside alone. Times derivative of the inside. So, g prime of f of g of x. Times the derivative of the inside. F prime of g of x. Times g prime of x. Times 1. We're done. We've reached the end. So this is one of those rules of a function and a function and a function and a function. Okay, so we're just going to go through and we're going to plug in 1. So h prime of 1. This is going to really test. Do you know how to read off the table? And do you also know how to be patient? Okay, so let's just work our way through here. G of 1. 2. So that's 2. That's 2. All right. F of G of 1. 3. G of 3. 1. So this is F prime of 1 times G prime of 3 times F prime of 2 times G prime of 1. F prime of 1, 2. G prime of 3, negative 5. F prime of 2, negative 3. G prime of 1, 2. 2 times negative 5 times negative 3 times 2 is 60. So that's 60. Now we're not done yet because it said find the tangent line, but we found the two pieces of information which matters. Y minus your y coordinate, our y coordinate is 52, is equal to our slope, 60, times x minus our x coordinate, which is 1. What do we do here? Box it. If you want to rewrite it, that's your choice because you like to live dangerously, but I like to be conservative. Save my points. Okay, question 4. Find the derivative of 1 over 2 plus root x using the limit definition of the derivative. Oh my goodness, I predicted 100%. Now it came true, right? Okay, so now you might say, wait, hold on a second. Aren't there two limit definitions? Yes, there are. Use whichever one you like, which means use the H one. That's the one you like. Let me be clear. There are two limit definitions. You like the one with the H. You don't like the other one. Okay. So, see, you've already forgotten that there's another one. Good. Good. That's how it should be. All right. So, you start by saying, I want to find this function. Okay, that's great. I do want to find that function. So I say, well, what do? It's the limit as h goes to 0 of my function where I put everywhere where I see an x, I put x plus h. This is the darndest hardest part of the problem. People don't know how to plug in x plus h in for x. Literally, everywhere we see an x, put in x plus h. If you can master that skill, that's like half the problem. And excuse me for saying darndest. Sometimes I get really passionate, and I get very salty in my language. Okay, so f of x plus h minus f of x all over h. That's the definition. Start with that. If you want, even literally just write f of x plus h minus f of x over h. Because they'll be like, cool, 3 points. Because that's where a lot of points come from. Maybe 2 points. I don't know. We haven't assigned points to these problems. If there is such a problem, who knows? I don't know. Okay. Now, what do? Clear your fractions. Look, I don't like fractions within fractions. Nobody does. So don't forget to write this limit as h goes to 0. Before you as long as you're taking that limit, you got to write it down. And do not, under any circumstances, write limit as h goes to 0 equals stuff. Because we are definitely taking that point off. Don't do it. Be smart. Practice safe notation. All right. So the common denominator, you multiply the two things together. So you would have 2 plus root x minus 2 plus root x plus h over h downstairs, 2 plus root x, 2 plus root x plus h. So that was a little bit faster than I normally go, but in the interest of time, I want to get through at least 5. And I got to go quick if we're going to get to number 5. What's number 6? Oh, okay. Anyways, so I just added the fractions together and said, okay, get rid of the fractions within fractions. Okay, now, what happens next will not surprise you. Cancellation almost always happens. And I really have upstairs square root of x minus square root of x plus h. Well, how do I get rid of square root of x minus square root of x plus h? What? Conjugate. I got to get that h out. I've got to free that h. It wants to be free. It wants to run around and play in the hills. So I'm going to use a conjugate, square root of x plus square root of x plus h. Square root of x plus square root of x plus h. Okay, so that's what I'm going to multiply by. If I do this carefully, upstairs what will I have? I'll have x minus x plus h. Yes, no? Yes. No. What's wrong? Parentheses. Parentheses are your friend. See, if you forget that parentheses, you forget a sign. And if you leave a minus sign off, we'll put another minus sign on. Minus 1 point. You don't want that. Okay. Be careful. Be careful. Downstairs, don't do anything. Don't do it. Don't resist the temptation to expand. Just leave it. Just don't touch it. Okay. Now, what happens upstairs? X's cancel. Then you really have negative h. But then what happens? The h's cancel. So what you really have is this becomes the limit as h goes to 0 of negative 1 over 2 plus root x times 2 plus root x plus h times root x plus h. And now what do? Plug in h equals 0. And you're not taking the limit anymore, so we don't write limit, because we've taken the limit. Negative 1 over 2 plus root x, 2 plus root x, root x plus root x. Let's clean this up a little bit. So negative 1, I see root x plus root x, that's 2 root x. And this is 2 plus root x quantity squared. Okay, that's part A. We've now done part A. This has a part B, which is to say, hey, couldn't you do it a better way? Like, aren't there rules? Yeah, sure. Which rule should we use? Chain rule? Okay, think of this as 2 plus root x to the minus 1. That's a nice way to think of this as a chain rule. Okay, so I'm going to use the chain rule. Chain rule? Chain rule is the best rule. Chain rule's the number 1 rule. Okay, negative 1 comes down. 2 plus root x to what power? Negative 2 times the derivative of the inside. Okay, derivative of 2? 0. Derivative of root x. Well, we don't think of root x as root x. We think of root x as x to the half. Derivative of x to 1/2 is half x to the negative 1/2. Okay, so if you clean this up, you're going to get negative on the top, 2 is downstairs, root x is downstairs, and 2 plus root x quantity squared. Now, the reason part B is here is to say, you know, you probably should compare your answers. Because what should be true? They should match. If they don't match, check both until you find at least one error. So this is sort of a built-in, I wonder if I got the right answer. If they both match, either you did it right or you're going to lose a lot of points. But more likely you did it right. Okay, that's number 4. Number 5. Okay, so you have this function f of x is quantity w of x plus v of x squared upstairs over q of x. You have a whole bunch of information. What's v of 7? And then find all possible equations of the tangent line to f of x. Now, I see a prime here. Do you see that prime, f prime of 7? This is primed to be a good question. So, what do? We start by taking f prime. What rules are we going to use to take f prime? Quotient rule and chain rule. So I'm going to take the bottom. I'm going to multiply that by the derivative of the top, which for me says I got to use the chain rule. The 2 comes down. W of x plus v of x to the 1 times w prime of x plus v prime of x minus, so that's bottom times root of the top, minus the top, w of x plus v of x squared times the derivative of the bottom, all over the bottom squared. Okay? Good. F prime of 7, because I know f prime of 7 is equal to 1. It's also equal to q of 7 times 2 times w of 7 plus v of 7 times w prime of 7 plus v prime of 7 minus w of 7 plus v of 7 squared times q prime of 7 all over q of 7 squared. Now at this stage we're like, oh my gosh, I hope things simplify. And they do, because watch. Q of 7 equals 1. So this is 1, and this is 1, and 1 squared is easy. Let's say w of 7 is 0. So this is 0, and this is 0. So that's pretty easy. W prime of 7 is negative 1. So that's negative 1. V prime of 7 is 3. So that's 3. Q prime of 7 is 4. So if we, that's left. We have 1 times 2 times V of 7 times 2. 4V of 7. So that's the first part. Remember, it's all over 1. Then I have 4 V of 7 squared. So minus 4 V of 7 squared. And that's equal to 1. Ah, that looks great. That looks like it's almost like a polynomial again. It's like we love polynomials because we love algebra. And so we're suspicious that we should get nice polynomials. So 4V of 7 squared minus 4V of 7 plus 1. What's our hope? It factors. Does it factor? Yes, it does. You get a factoring polynomial. You get a factoring polynomial. Everybody gets a factoring polynomial. In fact, it's a square. Wow. Okay, what does that say about V of 7? It's 1/2. In fact, the only possible value for V of 7 is 1/2. Now we know what V of 7 is. We wanted to find the tangent line to f, y equals f of x at x equals 7, but we didn't know f of 7. But now we can find it out. F of 7 is W of 7 plus V of 7 squared over Q of 7. But Q of 7 is 1. W of 7 is 0. And V of 7 is 1/2. So that means that F of 7 is 1/4. So I now know F of 7 is 1/4. And I know F prime of 7 is 1. So my tangent line, y minus my y coordinate, that's F of 7, 1/4, is equal to my slope, 1, F prime of 7, times x minus my x coordinate. And that's it. We're done. Positive 4, where? 2. Negative 1 plus 3 is 2. 2 times 2 is 4. And, oh, you don't even want me to talk about number 6? Okay, all right. Apparently there's a number 6. I'll wave my hands at it. You can leave if you want. So use the graph. This is a can you read the graph? So discontinuities. If I'm looking for discontinuities, where are their breaks? Well, you'll notice that if I'm drawing, I have to lift my pen up. Lifting a pen up is a discontinuity. So for A, x equals 3, that's a discontinuity, and it's a jump, because I have to actually move my pen. 4 is also a discontinuity, because I have to jump back and forth. Boom. But that's a removable, because I can remove it. How do I remove it? Well, the answer is you move the value up to there. You fill the hole. It's like there's a pothole, and we can remove it by setting g of x, g of 4 equals 3. That's how you remove the discontinuity. Okay. B, what is g prime of 2? Well, look at the function at 2. I want to know what's happening here at 2. Well, draw a tangent line. It's straight up and down. What's the slope of a line that goes straight up and down? Infinity. So g prime of 2 is infinity. Vertical tangent line is the reason. All right. C. Is there any place where the derivative is undefined? Well, is there any place where it's not smooth? 6. Any place where you have a kink is a place where you can't have a derivative, because if you zoom in, it's always going to have that bend. It's always going to be kink. So the answer is 6. It's kinked. So no derivative. Everywhere else, if you look close, it looks flat. All right. G prime of 7/2. 7/2 is a fancy way of saying 3.5. I want to find the derivative at that point. But look at the function. When you're looking at the derivative, you look close. You ignore everything else. What do you see? You see a line. And so if I'm finding the derivative of a line, it's the slope of the line. What's the slope of this line? Well, how far do I go? I go up 3 over 1. So what's my derivative? 3. Slope of line. All right, and finally for E, if I want to find 1 over g of x at x equals fine, first thing is just find the derivative. If you do the general inversion rule, minus g prime of x over g of x quantity squared. Look at 5. What's the derivative? What's the slope? Negative 1. So it's minus minus 1 over, what's the value at 5? 2 squared. So it's 1/4. Okay, good, done. And I know it took me more than 40 minutes to do this test, but you get 90. You'll have plenty of time. And you don't even have to do commentary while you do the test. You do it. All right, good luck.